Today I just want to talk about types of chemical reactions. And for us now, I'm trying to adjust this. We're just going to have to be able to identify a type of reaction that we have. The first type is synthesis. Sometimes they'll call this combination. So synthesis is that you're physically making something. Sometimes they call it combination. One thing about these, sometimes these reactions can be classified in more than one type. So just be aware. I'm aware of that. Just be aware of this. So basically for synthesis, you have two reactants. These are the reactants. And you form one product. So for us, just to kind of keep it simple, you go from two to form one. So two things will combine to form one. Like for instance, if hydrogen gas and bromine gas combine, they'll form hydrogen bromide. Hydrogen gas and oxygen combine, they'll form water. This one gives off heat. This is actually an exothermic reaction. This is how a fuel cell works, by the way. It gives off water and gives off a lot of energy with that. So again, combination, two reactants to form one product. So let's continue. Let's look at decomposition. This is basically the opposite of combination or synthesis. So basically, you go from one compound, say I have water. If I add some electricity to it, I'm going to break it down to hydrogen and oxygen gas. This right here, so I have to add some energy to it. This is called endothermic. So endothermic, you add some energy, you're breaking it down. So I go from one product to one reactant to two products. You can have more than two, but I go from one to breaking it down. To decompose stuff, a lot of times you just add energy to it. You heat it up, add electricity, whatever the case may be. This one right here is actually sodium bicarbonate. So this is baking soda. Baking soda, you add like a little bit of heat, you may add a little bit of acid. It's going to break down to form sodium carbonate, water, and carbon dioxide gas. Just be able to recognize it. So again, you go from one reactant to this case, you have three products. So it breaks down, it decomposes, it breaks down from one, and it breaks down to more than one type of product. Combination, the opposite. You're combining two, these are doing the opposite, you're breaking it down. So let's take a look at this one. This one, we call it an exchange reaction. And basically, ions are changing places. Like for instance now, if I have bromine liquid, and what happens in this case right here, just be able to recognize it, it's going to go ahead and knock off that iodine. And so it's going to combine with the barium itself. It kind of steals that barium away from the iodine. I'm left with iodine. You don't have to memorize the products, just have to be able to recognize. So I have this bromine comes in, replaces that iodine, and now I have barium bromide plus iodine. The other one now, I have zinc, comes in, knocks off that copper, so the copper gets knocked off, and reacts with the sulfate itself. So basically, you're exchanging ions with each other. Again, just be able to recognize that's an exchange reaction. Ions or metals, halogens are exchanging places. This is also another type of exchange reactions in which the hydrogen and the sodium exchange places. So now I form NaCl because the sodium replaces the hydrogen, and then the hydrogen replaces the sodium. I end up with HOH, which is just water. This also, you can call this an acid-base reaction. So this is hydrochloric acid and sodium hydroxide. This is acid plus base. Sometimes they'll call it a neutralization reaction. So again, just be aware, some of these reactions can fit in more than one category. This is a good example of it. Hydrochloric acid, sodium hydroxide, acid-base reaction. It's an exchange reaction. Neutralization, acids and base will form water, which is a neutral compound. So again, just be aware, you can classify it in more than one way. Let's take a look at a reversible reaction. A reversible reaction, I just want us to be able to recognize it. What happens is, for reversible, the reaction can go in both directions. So when I have a reversible reaction, it goes in both directions. Like for instance, this is dinitrin oxide, it can break down to form dinitrin tetroxide, and this can break down and go in both directions. So this is reversible. This reaction goes in back and forth. The way you can recognize it is that you have this is called an equilibrium symbol. So it means that this goes in this direction, this goes in this direction. They go back and forth, essentially. So that's a reversible reaction. Now, the ones we've been doing before, like say I have like sodium chloride. I can break that down to form sodium. This is like this. To form sodium plus chloride. This one only goes in one direction. So this is only one direction. That means at the end of the day, I'm just going to have sodium and chloride gas. And this one, I'm going to have both this and this in the reaction mixture. So this last one we're going to look at for this part is combustion. So combustion reaction is just like what you do every day. You start your car up. What's going to happen is you'll have gasoline. So this is actually gasoline in your car. When I say combustion, it's going to react with the oxygen. So in your car, you'll have like an oxygen sensor. It's going to react with the gasoline. You're going to produce carbon dioxide gas, water, and you're going to give off a lot of energy. So for all these combustion reactions, what's going to be the same is it's going to have oxygen gas, it's going to form carbon dioxide gas, water, and plus energy. And again, these are fuels. So combustion reaction are what happens to fuels. So you can have like this one right here is methane gas. This is the stuff in natural gas. So methane. Notice that the oxygen, this part is the same. So be able to recognize a combustion reaction. It reacts rapidly with oxygen. You form carbon dioxide gas, water, and you give off energy. And notice that the arrow goes in one direction. This is irreversible. So this is an irreversible reaction, exothermic, very, very exothermic.